Okay, guys, welcome. Today we're going to talk about some additional properties of linear equations. All right, and the first thing I want to talk about is the idea of horizontal and vertical lines. All right, now we saw before that horizontal lines have a slope of 0 and that vertical lines have an undefined slope. All right, so if you have a vertical line, that means that you have x equals something, right? So if you wanted to go through a point A comma B, then x equals A is the vertical line that does that, right? If you want a horizontal line, it's the same thing, except instead of x equals something, it's y equals something, right? And of course, a vertical line has not necessarily no slope, but we should say undefined slope. And a horizontal line has a slope of 0, right? So for example, in part A, we want the horizontal and vertical lines through the point -4, 7. Well, we know that a horizontal line is y equals whatever the y coordinate is, so it's y equals 7. And the vertical line is x equals whatever the x coordinate is, so x equals -4. All right, and it's as simple as that. For part B, the horizontal, right, we want it to go through the point 5, -6. So then the horizontal line, we know, is y equals -6, and the vertical line is x equals 5. All right, so those are fairly straightforward. Okay, now let's talk about sort of a related example. So we want to find an equation of a line that goes to the points 4, -1, and -5, -1. All right, well, the first thing we need is we need the slope. Right, so if we find the slope, we have to do m is equal to y2 minus y1 over x2 minus x1. So we'll get a -1 minus a -1 over a -5 minus 4. So we're going to get a 0 over -9. So that's just 0. Well, as soon as you have a 0 slope, we know that that's a horizontal line. So of course, this tells us that y, since it's a horizontal line, y equals whatever the y coordinates are. So in this case, we get y equals -1. Okay, and then part B, now our coordinates are 6, -1, and 6, 7. So again, we need the slope. So if we do 7 minus -1 over a 6 minus 6, we get 8 over 0, which is undefined. So as soon as we get undefined, that tells us that it's a vertical line. And so we're just going to get x equals whatever our x coordinate is. So in this case, x equals 6. Okay, so that's the idea behind horizontal and vertical lines. Okay, now we're going to talk about parallel and perpendicular lines. All right, so of course, we know that parallel lines are two lines that are never going to intersect each other. So it might look something like this. And of course, the idea is that we want to, sort of the mathematical way to think of this is that in order for these lines to intersect, they need to have the same slope. Okay, so we're going to use that to our advantage. So in example 3, we want to find the slope of every line that's parallel to y equals -2/3 x plus 5. Well, if we want something parallel, we want our slope to be the same as this. So we also want our slope to be -2/3. Right? And then in part B, we have y minus 4x plus 5 equals 0. So first we need to write this in slope-intercept form so we can see what the slope is. So if we do that, we need to move the 4x and the 5 over. So we're going to get that y is equal to 4x minus 5. Right? Now this tells us that the slope is 4. So we want, since it's parallel, also have slope 4. Right? So that's the idea. So if you want two lines to be parallel, you need them to have the same slope. Okay. Now, in example 4, we're going to find an equation of the line that passes through the point 2 comma negative 1, and we want it to be parallel to y is equal to just positive 1/2 x minus 5. Okay, well, if we want to be parallel to this, we better have slope 1/2 also, right? Because it better have slope. Well, now we have a slope and we have a point, so we can use point slope form. So we can use y minus y1 equals m times x minus x1. So if we plug in, we're going to get y minus negative 1 is equal to m 1/2 times x minus 2. Of course, if we simplify, we're going to get 1/2 x minus 1. So if we subtract 1 from both sides, we're going to get that y is equal to 1/2 x minus 2. Okay, so that's our equation of the line that passes through 2, negative 1, and is parallel to y equals 1/2 x minus 5. Okay, now in part B, we want to do something similar where we pass through this time negative 8 comma 4, and we're parallel to y equals 2y equals negative 2. No, sorry, not equals yet. It's just 2y minus 2x plus 17 equals 0. Okay, so of course we want this line slope, right? So we need to move the 2x and the 17 over. And we're going to get that 2y is equal to 2x minus 17. So then when we divide by 2, we're going to get that y is equal to x minus 17 over 2. So that tells us that we want our slope to be 1. Right? Well, now we'll just use point slope form again. Y minus y1 equals m times x minus x1. And we'll plug in y1, which is 4, m, which is 1, and x1, which is negative 8. So we get y minus 4 is equal to x. This will become plus 8. So once we add 4, we get y is equal to x plus 12. Okay, so there's our solution there. Okay, now if you talk about parallel lines, we should also talk about sort of the opposite of that, which is when you have perpendicular lines. All right, now perpendicular lines, not only do they intersect, but they sort of intersect at like a direct hit, right? They intersect at a right angle, right? Now, if they're perpendicular, then what can you say about these two slopes? Well, you can say that one of the slopes is negative 1 over the other slope, right? The way that I usually think about this is that if two lines are perpendicular, then the slopes are opposite reciprocals of each other. And of course, opposite just means different signs. So one's positive and one's negative. And reciprocals means that one is flipped. One is the other one flipped. Okay, so let's go ahead and we'll take a look at that. So in part A, we want to find an equation that passes through negative 3 comma 4 and is perpendicular to y equals 3x minus 2. Okay. Now, if it's perpendicular, we don't want the same slope this time. So this slope is 3. And of course, I can think of that as 3 over 1. Since I want perpendicular, remember we need opposite reciprocals. So opposite means that since the first one is positive, I need mine to be negative. And since the given line is 3 over 1, I want this to be 1 over 3. So that's the slope that we want. So now we just use this point and slope, point slope form again. So we're going to get y minus y1, which is 4, is equal to m, so negative 1/3, times x minus a negative 3. So we get y minus 4 is equal to negative 1/3 x. Don't forget this will become plus 3, so then we'll get a minus 1. And then add 4, and we'll get y is equal to negative 1/3 x plus 3. Right, so again, for perpendicular, you need opposite reciprocal slope. Okay, finally for part B, we want to pass through 2, negative 3, and be perpendicular to 2y plus 4x minus 1 equals 0. So again, we don't have the slope right away, so we want to get that first. Okay, so we need to put it in slope intercept form. So let's move the 4x and the 1 over. And we'll get that 2y is equal to negative 4x plus 1. So then when we divide by 2, we get that y is equal to negative 2x plus 1/2. So now we have that this slope is negative 2. But again, remember we want perpendicular. So we don't want the same thing, we want opposite. So we'll think of this as negative 2 over 1. So opposite would make this positive, and if I flip 2 over 1, I get 1 over 2. So we're going to use 1/2 and 2, negative 3. So if we plug this in, we're going to get y minus negative 3 is equal to m, which is 1/2, times x minus x1, which is 2. So if we simplify, we're going to get y plus 3 is equal to 1/2 x minus 1. So then subtract 3 from both sides. And we're going to get y is equal to 1/2 x minus 4. All right, so that's our line there. Okay, now I believe, yeah, so this is the last example that we'll do. And we want to state whether each set of lines that we're given is parallel, perpendicular, or neither. Okay, so in the first one, we have y minus 3x plus 11 equals 0. And we have 2y equals 6x minus 4. So of course, to get the slope of each of these, we need to get y by itself. So to get y by itself here, I'm going to get y is equal to 3x minus 11. And then here, if I divide by 2, I'm going to get that y is equal to a 3x minus 2, right? So now the slope of each of these is the same. We have m equals 3, so that tells us that these are parallel. Okay. Part B, which I'll do up here so I can try and save some room. We get y equals negative 4x plus 1, and y is 2y is equal to negative 4x plus 9. Now this one we can already see that the slope is negative 4, but this one we need to divide by 2 first. Okay, and then if we do that, we see that the slope is negative 2. Now, of course, these slopes are different, so they can't be parallel, but they're also not opposite reciprocals. So this is an example of neither. Okay, part C, we have 3y minus x minus 7 is equal to 0, and 2y plus 6x plus 8 is equal to 0. So if we solve each of these, first, if I add x and 7 to both sides, I get 3y is equal to x plus 7. And then if I divide, I'm going to get that y is equal to 1/3 x plus 7 over 3. So we get a slope of 1/3 here. Okay. In the next one, if I move the 6x and the 8 over, I'm going to get that 2y is equal to negative 6x minus 8. Right? And then if we divide by 2, we're going to get that y is equal to a negative 3x minus 4. So here we get the slope of negative 3. So now if we compare these two, we see that they are opposite signs, and one of them is the other one flipped. So they're opposite reciprocals, so these are perpendicular. Okay, let me get myself a little bit more room. Okay, for part D, we have 4y minus 6x is equal to 11. And we have 3y plus 2x minus 7 is equal to 0. Okay, so if we get y by itself, this will be a 4y equals 6x plus 11. And then once we divide by 4, we get y is equal to, once we simplify, 3 over 2x plus 11 over 4. So we get a slope of 3 over 2. If we get y by itself here, we're going to get that 3y is equal to negative 2x plus 7. And if we divide, we'll get negative 2/3 x plus 7 over 3. So this slope is negative 2 over 3. So these are opposite reciprocals again, so these are perpendicular. Okay, so a little bit more room for part E and F. Okay, so part E, we have 9y minus x plus 16 equals 0. Was it minus, okay. And then 3y equals 9x plus 4. So if we get y by itself, here we'll get a 9y equals x minus 16. And then dividing will give us y equals 1/9 minus 16 over 9. So m is equal to 1 over 9. Okay, and then here if we divide by 3, we get y is equal to 3x plus 4 over 3. So this slope is 3. So this, of course, is an example of neither. And then finally, part F, we have 5y equals x minus 4. And the other one is 25y minus 5x. And then what was the rest of it? Plus 17 equals 0. Okay. So now if we get y by itself, here we'll get a y is equal to a 1/5 x minus 4 over 5. So we have a slope of 1/5. And then here we have a 25y is equal to 5x minus 17. So we get y is equal to 5 over 25, which is 1/5 x minus 17 over 25. So m is 1/5. Both of these are the same, so they are parallel. Okay, so that concludes this video on some additional properties of linear functions. I hope you enjoyed, and I will see you next time.